An arithmetic series has first term a and common difference d. Prove that the sum to n terms of the series is n by 2 into 2a plus n minus 1 into d. So we know sum of n terms is equals to the first term we know it is a, second term is a plus d, etc. up to the last term a plus n minus 1 into d. If there are n number of terms, then the last term will be a plus n minus 1 into d. The first term will be a, second term is a plus d. So it goes on like that. So I have kept some space in between each terms here. So now I'm going to write this sum of n terms once again, but I'll be starting from the back. So here I'll write the last term, that is a plus n minus 1 into d plus etc. And then we know the second last term will be a plus d plus the last term will be a. Now I'm just going to add them, add both of these equations. Sn plus Sn will give you 2Sn and a plus n minus 1 into d. So the first term from both of these equation, right hand side, a plus n minus 1 into d will give you a plus a is 2a. So 2a plus n minus 1 into d, etc. up to, when you check the last term here, the last term is also what? A plus a plus 2n minus 1 into d. That is a plus a is 2a, 2a plus n minus 1 into d. Now, we will be getting 2a plus n minus 1 into d n number of times because we know that there are n terms here. We have considered that there are n terms here. So, when we add both of these equations, we will be getting n number of times 2a plus n minus 1 into d. So, this can be written as 2 times Sn will be n times we are getting what? 2a plus n minus 1 into d. Now, so just take this 2 to the other side to get sum of n terms. 2 goes to the other side, it becomes n by 2 into 2a plus n minus 1 into d. So we proved it. So just write down the sum of n terms 2 times and then you just add them both. You'll get the answer here. Now in the second subdivision, the first part, nth term is given as 5n plus 3 minus 1 to the power of n. So here, fifth term, definitely we know fifth term will be what? Fifth term will be, just replace n with 5. So 5 into 5 plus 3 into minus 1 to the power of 5. So minus 1 to the power of an odd number. If it's an odd number, then we will take it as negative 1 itself. If it was minus 1 to the power of any even numbers, we will take it as positive 1. So we know the rule that minus 1 to the power of any odd number, this is equals to minus 1. And minus 1 to the power of any even number will be positive 1. So this is 5 into 5 is 25 plus 3 into minus 1 to the power of an odd number will be minus 1 itself. So this will give us 25 plus 3 into minus 1, that is minus 3. 25 minus 3 is 22. So we got the subdivision A answer here. Fifth term is 22. Now we need sum of first term to 59th term of un. So what we need to do is we need to find out some pattern from this nth term given here. We need to find a pattern and then we use arithmetic or geometric sequence. Let's see the pattern here first. To get the pattern, we need to at least find first 5 terms. Fifth term is already here. So first term will be what? 5 into 1, instead of n you replace it with 5. So 5 into 1 is 5 plus 3 into minus 1 to the power of 1. 1 is an odd number. So 3 into minus 1. 3 into minus 1 is minus 3. Second term, 5 into 2 is 10 plus 3 into minus 1 to the power of 2. n will be replaced by 2. So n is 2 is an even number. Minus 1 to the power of 2 is positive 1. So 3 into 1 is 3. The third term here, 5 into 3 is 15 plus 3 into minus 1 to the power of 3. 3 is an odd number. So minus 1 to the power of 3 will be minus 1 itself. So 3 into minus 1 will be minus 3. Now, fourth term we have here. Fourth term will be 5 into 4 is 20 plus 3 into minus 1 to the power of 4. 4 is an even number. So minus 1 to the power of an even number will be positive 1. So 3 plus 3 this will be. Now, fifth term is 5 into 5 is 25 plus 3 into minus 1 to the power of 5. 5 is an odd number. So minus 1 to the power of an odd number is minus 1. So 3 into minus 1 is minus 3. So this will be minus 3. Now we can see the pattern here. This forms an arithmetic sequence here. 5, 10, 15, 20, 25. This forms an arithmetic sequence with the first term as A and common difference as D. And then we have minus 3 plus 3 minus 3 plus 3 recurring. So what we can do is, first let's find out 59th term of 50, sum of 59 terms of this arithmetic sequence. That is 5, 10, 15, 20, 25, etc. Let's find out the sum of n terms or sum of 59 terms here. Sum of 59 terms will be n by 2, that is 59 divided by 2 into 2a. A is 5, so 2 into 5 is 10 plus n minus 1, that is 59 minus 1, that is 58 into d. D is what? Common difference is 5. So this will be 59 divided by 2 into, let's just put that in calculator, 58 into 5 plus 10, which will give you 300. So now 300 into 59 divided by 2 will give us 8,850. Now we have, again we have a periodic sequence, we can say. The values are repeating. So minus 3, so minus 3 plus 3 minus 3 plus 3, etc. It goes 59 times. So if it goes 59 times, throughout first 58 times, when you add them up, we will get 0, because minus 3 and 3 gets cancelled, minus 3 and 3 gets cancelled. So this keep repeating till 58 term, it just gets cancelled. Minus 3 and 3 will keep repeating and it gets cancelled. And 59th term will be minus 3. So that minus 3 will be still remaining. So along with this 8,850, you subtract that 3, you will get 8,847. This will be the final answer. Or else we have one more method here. The other method will be 5 minus 3 is 2, 10 plus 3 is 13, and 15 minus 3 is 12, 20 plus 3 is 23, 25 minus 3 is 22. So I can see that this forms an arithmetic sequence, that is 2, 12, 22. And again, this also forms an arithmetic series, 13, 23, 33. So 13, 23, 33, etc. So I know this arithmetic sequence, the one which I have circled here, will contain 30 terms. This will contain 30 terms. And here, because 1, 3, 5, etc. up to 59, 1, 3, 5, etc. up to 59, there are 30 terms. Whereas 2, 4, 6, etc. up to 59, there are only 29 terms. So this will be 29 terms here. Now we just have to find out the sum of first 30 terms, sum of first 29 terms, You add them both, you will get the answer. So sum of first 30 terms will be n by 2, that is 30 divided by 2 is 15, into 2a. 2 into 2, that is 4, plus n minus 1. 30 minus 1 is 29, into d. D is 10 in this case, so 290. So 294 into 15. So 294 into 15 will give us 4,410. Similarly, here, sum of first 29 terms, that will be n by 2, 29 by 2 into 2a, that is 2 into 13 is 26, plus n minus 1, 29 minus 1 is 28, and common difference is again 10 here, therefore 280. So 280 plus 26 multiplied by 29 divided by 2 will give us 4,437. Add these both. 4,437 plus 4,410. It will give you 8,847. So both the method, you will still get the same answer. So here, the first method, I used this 5, 10, 15, 20, 25 as the arithmetic sequence. And then, minus 3 plus 3 minus 3 plus 3, it gets cancelled all the way till 58th term. And then 59th term will be a minus 3. So find out the sum of first 59 terms for this sequence and just subtract 3 from it to get the answer. That is a much simpler way to solve that. Or else, can just see the first term is 2, 13, 20, 12, 23, 22. It goes like that. So now we can see that the alternative terms are forming an arithmetic sequence 2, 12, 22. So first you find out the sum of first 30 terms of that sequence, and then the next, the even numbers, 13, second, fourth, those terms are also making an arithmetic sequence. First, 29 terms. Add them both, you'll get the answer. So if you have any doubt, feel free to write it in the comment box. Thank you for watching.